Hello class, welcome to another math tutorial. This time we are going to solve, or I will be giving you an example on how to solve a standard deviation. Let's start. Okay, we have here. Consider this following problem class. You have found the following ages and years of four bears. Those bears were randomly selected from the 22 bears at your local zoo. So we have here 5, 4, 6, and 39. So based on your sample, what is the average age of the bears? And what is the standard deviation? So round your answers to the nearest tens. So as I've said last time, you can have at least two decimal places, or if you say tenths, so tenths is just only one place, one decimal place. So first thing to do, because we only have, okay, consider understanding. Okay, this needs a deeper understanding class because we only have a data here for a sample size of how many bears? Yes, 22 bears. So we are only able to estimate the population mean and, of course, the standard deviation. Okay, so we are going to find the sample mean and, of course, the standard deviation. Class, we cannot get the standard deviation if we don't find the sample mean first. So find the mean first. Mean meaning sum of all data divided by the number of data sets. That is 5 plus 4 plus 6 plus 39 divided by 4 because that is our formula. So we have to consider the formula in finding the mean. Now, if we are going to add those, we can have 13.5 years old as our mean. Question, teacher, why do we need to find the mean? So remember last time, as I've shown you in the table, we have tables last time. You were confused. Where is this came from? Why is this like this? So here, consider that these are the ages. So these are the numbers earlier, the 5, the 4, the 6, and the 39. So remember that in doing the table, after you get the mean, you can create a table. So stating here, we have the x sub 1 or the first x, which is either 5, 4, 6, 39, minus this. What is this? The mean. That's why we need to get the mean so that we can get these numbers. And after that, squared raised to the power of 2. Teacher, why is this negative 8.5? Because, as I've said earlier, x sub 1 is the first data set, which is the 5 years old, minus what is our mean? 13.5, which is equal to negative 8.5. That answers our negative 8.5 here. So that is now our what? This is now our first column in the distance from the mean. Teacher, okay, another set of question here. We have, teacher, why is this negative 9.5? So as again, just simply use the formula in the second column, which is x sub 1 is the second age, which is 4, minus the mean that we get earlier, which is 13.5. So that gives us negative 9.5. Does it answer the second column, class? Okay. Now let's have the third column, which is why this is 72.25 years, teacher. It's because it says that the result of the second column, you have to raise that to the power of 2. What does it mean? Meaning you are going to multiply the second column twice. So negative 8.5 times negative 8.5 will give us positive 72.25. I know you got it, class. You are smart. Believe in yourself. Okay? Now, let's do have the second one. In the second one, why is this positive 90.25, teacher? It's because the result in the second column for the 4 years old, we have negative 9.5 times negative 9.5. So when we are going to multiply this, since it's a squared, so only 2 times, so equals 90.25. Gets now. So we are already done. We get the second column, we get the distance, and we get the squares. So it's not yet done because we still need to get the standard deviation. So take a look at this one. In getting the standard deviation, we have the formula of, can you still remember the formula? Of course, you have that in your paper or in your notebook. S squared equals the sum for the first axis or the first data set minus the mean raised to the power of 2 over n minus 1. Class, do not be confused of this one. Why? This is what you did earlier. Where, teacher? That is what you did in the columns that we did earlier. Take a look. This is it. Okay? So after you get the mean, where is the mean? Teacher, I forgot to get the mean. Again, the mean. So after you get the mean earlier, which is 13.5 years old, we then proceed in getting the table. So we're already done. We get this one, x of 1 minus the mean raised to the power of 2, or in the second power. Now this time, we are going to solve for the standard deviation using the formula over n minus 1. These numbers here, class, are the results in the third column earlier that we had from the table. You add this. Last time, we subtracted it, but the correct way is adding it. Okay, please be reminded for that. It's addition. So you add all the results in the third column divided by what is n, teacher? Meaning how many data sets you have there. We have 4 data sets, the 5, the 4, the 6, and the 10, right? Okay, 4 data sets minus 1. So they have differences when it comes to the mean because the mean didn't say any minus 1. But when it comes to standard deviation, we have minus 1. So when you add all of this, when you get the sum, we have 869. 4 minus 1, we have 3. And the answer is 289.67 years. Is it done? Not yet, of course. Why? Because we still have squared to do. So what are we going to do? The root, the sample standard deviation is found by taking the square root of the sample variance. Remember, I have discussed this before. So s squared, multiply both sides by the what? The square root. So our answer is the square root of 289.67 equals 17 years. Okay? So how did we get this? If you have the calculator class, you can just simply input the radical sign and input 289.67 so you can get 17 years. Please keep watching this video on how to solve standard deviation. I hope this helps, class.